are very different from the seawater that surrounds this area. We also want to see how the gradients change over the spatial distances that we're sampling.
Okay, thank you.
Can we have a quick temperature update on both?
Yeah,
Please.
IGT's at 5.53.
I got temperature of 5.
Okay. Great, thanks.
Stopping sample.
Copy that, stopping sample, 2039.
And flow counts is 41962.
41962.
Total volume of 15.9 liters.
15.9 litres. Thanks, Eric.
The low temp on that for the IGT was 1.91 and the high of 15. But it was mostly around like 5 to 8.
Okay, 5 to 8. Low 1.9, high 15.1.
I got a low of 1 degrees and high of 9.
Okay, this was super.
What was your low on that?
Low of 1,
1.91.
high of 9 on the super.
You won't be able to reference these logs for the max because I always start it when you're still searching for your spot. So
Let's move let's move to the left side of that vent flow. So if where you're at, just move further to the left, where the bounds of it are.
Here?
Yeah. Let's see what we get there.
Okay, I'm all stopped there.
Kind of seems like background seawater.
What are you guys reading?
mine is fluctuating 2 to 10 or so. Right now it's at 4.72.
Mine's holding around 1 to 4 degrees C.
Thank you.
Let's move the one forward an inch.
Forward as in towards the vent?
Yes. Who's breathing into the mic? It was the Phantom. Alright, I'll take a sample here. Starting.
Starting now, was that?
No.
Sorry.
Now. 204430.
Starting sample now, 2044. And what temperature readings do you both have?
IGT is currently at 29, but fluctuating into the 30s.
I'm reading 19 degrees C.
19.
Mm-hmm.
Thank you. You got your frame grab. Perfect, thank you. Eric, are you happy with bubble on the wand at the moment, or do you want a quick visual on the paddle wheel?
Yeah, we can check out the paddle wheel. Pretty sure it's flowing though.
Yeah, quick visual check.
On the flow meter?
Yes, please.
Yeah, got it.
That's good.
Yeah, it's good.
Thanks, Cassidy.
You're welcome.
Wow, it's getting really low suddenly.
I think it's just a function of that vent fluid wafting back and forth.
Yeah.
What have you just gone down to?
5.35.
Wow.
I'm at 9.
So I have a high of 40 and a low of 5.3.
Wow. Yeah, it's right on the edge there, isn't it? So you're going to get huge fluctuations.
So your low is 5?
Mm-hmm.
What'd you read for high? 32?
What was that?
What was your high?
My high was 40. This is the 42s from before we started sampling.
Stopping flow 2049.
Copy that, stopping at 2049.
And flow counts is 47942.
47942.
Total volume 17.1 liters.
Great, 17.1 litre total volume.
So they really want me to take all the samples here?
Yep, it says 14.
We're not going to any other vent sites?
Not to do any more sampling, so I think they've, yeah, at this site it was to use all 14.
Okay.
Yeah, Eric will then select a series
Excuse
of
me.
up to, oh, it says up to 14
Up to
discrete.
14.
Yeah, so I suppose that's up to your discretion.
Yeah. How far high can you reach, Trevor? On that plume? That,
I can reach a lot higher if I'm allowed to twist it so it's pointed up.
you can do that. I'd be okay with that.
Okay, can I come full wide on the Zeus, please?
Absolutely.
Do we get a picture of this one?
Oh, did you want the picture
For your
They,
reference?
they got a picture, yeah.
Yeah, I got a picture.
Okay.
Okay, I'll just keep moving it up and you tell me what makes you happy there, Eric.
Okay.
What makes you truly happy in life?
That's a very loaded question, buddy.
M&Ms are a good start.
Yeah. Got any more?
Yeah.
We didn't eat lunch back here.
Can you zoom in on Argus Zeus, please?
Huh, that's
It's
interesting.
gonna be
I'm
hard
like
with the
50
bounce.
degrees. So even if we're like in a plume pretty high, we're getting pretty high temperatures. See that?
You're higher than me for once.
Yeah.
Do you want me to keep going? I don't know how much more I want to stretch this.
No, don't stretch it any more than that.
Okay.
This is good right here. Let's see what if we can sustain the temperature.
I couldn't tell you for sure if I'm in the, oh, let me try this.
Can you tell on the Argus cam?
Hard to see. I'm going to
Are you
turn
able to-
some, can I turn some lights off so I can kind of decrease the contrast there and maybe we
Yeah.
can,
See if I
See
can
it a
help
bit
you
better.
get something.
okay, lights coming off. Let's try turning this one off. Nope, I want that one on. I want this one off. I'm going to try some weird stuff here.
How about it?
I want this one and not this one. Or maybe this one and not this one?
Hold on, let's see
That's
what
not bad,
The
actually.
lasers.
You can definitely see lasers now. Lasers going right through the vent flow.
Yeah. That's a neat backlighting
Yeah.
there, actually.
That's a
We're sustaining
intense
about 30
refraction.
degrees, 35.
Yeah.
I think you're in partially in the vent flow, yeah.
Yeah. Let's try this one. I'm going to sample at, let's see.
Are you still full wide there, Jess?
Yeah, this is as wide as Hurt can get, I think,
Let's see if I can line up the,
without the vignette.
yeah. You can just see the orifice now there, Aubrey, if you want to grab a screen grab.
Sounds good.
We're standing by, Eric.
Yeah, let's take a sample at 2053.
2053, standing by.
You're holding steady at 30 degrees?
Pretty much 31 to 35.
Starting sample.
Copy that, starting sample 2053. What are your temperature readings?
Mine's at 35, plus or minus 4.
I've got 42 plus or minus 4 degrees.
Thank you.
New low.
Bless you.
Thank you.
set. Graham crackers. On.
So Eric, just to relay what's written here, it says the general intent is to have the ROV pilot pick up the super inlet wand and move it around as instructed by Eric, both vertically and horizontally at 0.5 to 2 meters above the same vent sampled for the IGTs. Allow Eric to determine the size and nature of the gradients in the in-situ sensor data, starting with temperature, in the water column immediately overlying the vent site. From the information, Eric will then select up to 14 discrete locations at which we will ask the pilot to hold the manipulator arm stationary while he collects the super tube samples. So yeah, up to 14.
You'd say that's probably almost a meter up high above the orifice, right?
I would say that's over a meter.
Over a meter?
I'd say from to the tip of the wand, 1.5, probably not 2, but probably 1.5 meters.
Okay.
Maybe 2.
Can we get a temperature update, please, guys?
Yeah, the IGT is at 35 right now. Currently, the high was 37.77, and the low is 20. You're on. Nope, now you're off. You're on.
I'm at 43 degrees.
43, thank you.
Now you're on.
I'm gonna stop sample.
Confirm that, stopping sample, 2057.
We have an end flow count.
Inflow count is 54338.
54338.
Final volume 18.3 liters.
18.3 litres. Did you want a frame grab with the lights on as well? I don't know how different it looked.
Hey Trevor, can we turn the lights back on to get
You bet.
another frame grab?
We got an image of that one.
There's some lights for you.
What's that?
We got images of that one.
I think you guys got images of that before, right?
I did,
Okay.
in the low light, and then we'll take it in the lights also.
Okay.
Now the wand descends into darkness. I thought that was really neat lighting with just the porch light on there.
Yeah, it looked good over here. How's that for you, Aubrey?
That looks good.
I'm gonna take one more sample within the light range to the left of the field.
To the left of the field, okay. So kind of where the lasers are, left laser is now?
A little more left of that.
More left of that.
Yeah.
Okay. You want me to move right now?
Yes, please.
Okay. Jess, can I get some focus, please?
That's as far in as I can get without zooming in more.
How's that there, Eric?
Yeah, let's hold it there for a minute.
Okay.
You can keep them.
How are we looking in terms of temperature?
IGT is at 1.73 currently, fluctuating from there to about 3 degrees, and the super wand is about 3 and 4. You're not on.
SPL, Eric, sorry.
It's at 3 degrees now, but it dropped from like our last temperatures. Took a while for it to cool down. So I think we're noticing a thermal loading effect on the wands.
On the ones
Yeah.
taking the time to
Cool
get
off.
back down, yeah.
Yeah.
Are you interested in actually getting a sample outside of the influence of the flow altogether, or
Yeah, that's what I'm.
is that what you're
trying
hoping for now?
Yeah, since we're getting pretty low temperatures, it's likely this is out of the total flow, so I'm going to grab a sample here. And this will be sample 10.
I'll stay locked in there.
Yes, please. And we'll start at 2102.
2102, standing by.
You guys want me to zoom out on Argus? Or
Starting
where
sample.
it is now?
Copy that, starting sample, 2102.
Yeah, you can zoom out slightly.
It's okay.
Can I get some temperature readings?
Yep, IGT's at 2.38.
Super's at 2 degrees.
Bless you.
Bless you.
Thank you. Hey Trevor, are we drifting?
Yep.
Gonna pause sample.
That's weird.
Copy that, pausing sample.
To stay stationary for 2 hours and then all of a sudden come adrift. I don't really understand it, but
It was a fish.
I think so.
Just came up and gave us a shove.
Yeah, do you want me to reposition that wand?
Yeah, let's get a little closer to the vent field and wait for the dust to settle a little bit.
Okay, I guess I'm stable here again. I can move the arm.
Yeah, move it closer. Stop right there.
I'm kind of in with the
Oh,
sensitive bits in the vent. I don't really like that.
you want to reposition? Or you can bring your arm closer in and then just stick the wand outward.
Sure. How's that?
Yeah, let's try that for a minute. Pretty low temperatures. That's good.
Yeah.
What are you reading now?
IGT's at 1.53.
Mine's at 1.6 or so.
Okay. And
They're-
obviously we're going to have to wait for all the flock to settle out.
Yeah, I'm
You
gonna
don't
wait
wanna-
for everything to stop for a minute, and then I'm gonna restart the sample as like a new sample. Just flush it.
Okay, but it will still be into tube 10.
Yeah, still 210.
Okay.
Yeah.
So we're gonna change the starting flow count to 55754.
Copy that, starting the flow count at 55754.
Yep. Restarting sample now.
Copy that, starting sample 2106. And do we have an updated temperature?
Can you come down on your delta a little bit, please?
Currently at 1.55 for the IGT.
Just like 2 meters down.
1.49 for the super wand.
Thank you.
Great, thank you. Sorry? Yeah. It's 40 meters away.
You can make a note that this is outside the vent flow.
Yep, copy that.
Got that.
Is anybody opposed to me removing eyes
Yeah, go ahead and
from
zoom.
the flow meter?
Yeah, you can move it.
Thanks. It's you.
Roger. It's me.
Yeah, I think it's just the way the light's bouncing off the hoses.
Could be totally, yeah.
We can get another temperature update.
IGT's at 1.78. Super wand at 1.42.
Thank you.
Stopping sample.
Copy that. Stopping sample 2110.
Final flow counts 61189.
61189.
Total volume of 15.5.
15.5. Thank you.
Contemplating sticking it in the hottest place possible. I probably won't put it in very hot stuff. We already got a sample that was at like 115, right? That was like S5. Let's get one more high temperature sample. So I'll move into the vent flow higher, and then we'll move it down.
Can I get bubble on the wand tip, please? How's that looking?
It's growing. I'm at 92 degrees.
I'm at 42,
That might spice it up
70,
there.
92, 111, 125,
Ah, a little hot.
134,
Move it vertical from there.
I pulled it out.
dropping 103, 95, 75, thinking 28.
Yeah, I think we're out of the flow right now. Could try putting it in 1 inch. Leave it there for a sec.
Growing. $90, dropping 74.
I think we're on the edge.
Can you give me some more delta, please?
Increase delta?
Decrease the delta, sorry. Yeah. Come down.
About 12? Is that okay?
Probably 15.
15. Goodbye, fishy. We'll just hang out there.
Seems to stabilize around 60. Can we move it in
Yeah.
an inch?
Move it in an inch. Roger that.
$88, 94, 99, 103.
Holding there.
Yeah, 98 again, dropping a little.
The current's changed. Argus is now a lot more south of Herc than it was. Sorry, this is the subsurface current, the bottom current.
Just checking out.
113, 116, 18,
I'm even
19,
thinking
20, 122.
Might be okay with a ship move, yeah. Yeah, so I want to go like kind of that way, like due north
How's your
kind of
comparative reading on the
Maybe
Super
10 meters
Eric?
due north.
I'm reading 74 degrees, but IGT's reading 118.
040 LS.
I think it's the limit
exactly.
of
So I don't
where
want to
I
get
wanna take
closer. I
due
want to get
north. Due north.
All right.
more behind, yeah.
I'm going to just do 5 meters. So.
Trevor, are we okay to take a sample here?
I'm okay to take a sample here, yep.
Okay.
Sure. Or 10.
Starting sample 11 now.
Copy that. Starting sample 11 now. 21:15.
What temperature do you want me to... are we going to pull if it gets too high?
No, I think this is around the edge of it.
All right.
Is it going 136 now?
Yeah, 136. The high right now is 137.
Trevor, could you move it up half an inch?
139, 140.
You're a little nervous. You continuing with the sample, Eric?
I paused it for a second.
Okay, pausing sample. Copy that.
We're going down 82, 81.
Can you push it into the vent flow a little bit?
Zoom in, please.
Growing.
Thank you.
A little bit. 97.
I haven't moved it yet. You want me to still push it in half an inch?
Yes, please. Oh, not down, forward.
Yeah, that was the wrong movement.
All right. We're at 80.
That's lower.
Yep,
Oh no, it's going back up. Or not.
kind of. Sometimes. 87. 89.
Let's move it a little more in, Trevor.
More in, Roger.
108. 109. 115.
That's about where we were, right?
Yeah.
Let's watch it stabilize. 26, 19. Seems to be staying around closer to 130. Can we move it up half an inch?
Up half an inch, yep.
Just a smidgen.
One smidge.
Very scientific.
112.
The cliff is north?
This seems
So
like a
little-
safer
Oh, I think we're already
spot.
on the
Yeah.
wrong side of it. That's the problem.
Commencing
Okay.
flow back collection.
Okay, copy that. So restarting at 21:18. And do we have a new flow count?
Yeah.
Yeah, 6, 2,
Yeah, you'll see it in like
1,
5 minutes.
0, 0.
62100.
Was that 10 meters?
I did 10 meters.
Great, okay. That'll be perfect, I think.
Copy that. And if we can have a temperature update for this new restart.
IGT is currently at 113.57. Super is at 101.
Great, thank you. And can we fix the field of view again so we can have the orifice at the bottom of the field of view?
Go ahead and zoom if you want.
Was that like about
But
30 centimeters high?
I'd agree with that. That sounds right.
Yeah, I reckon.
What are you seeing, Ben? Oh, okay. I mean, that should be okay.
Yeah, I think it's fine. I just
Yep.
want to be aware.
Good to be careful. That changed quite a lot, actually, that current. I wonder if we should do another 5 or 10. Maybe 5.
I would not be opposed to that.
All right. I'll just put in now. 5 meter.
27 knots.
Can we get a temperature update when you're ready?
Yeah, it's been between 25 and 27.
I'm
Before
getting
it was like
111.
23, 25.
They're already doing 100%.
I'm at
thrust. I don't know
121.
if they'll be
Yeah.
able to do a step forward.
121
Yeah.
and 111 was that, Eric?
Yes.
Thank you.
Yeah, let's do a 5 meter step.
Yeah, got
Just
it.
see if they can. There's a test of their stuff as well as
Right. He put it in.
seeing some limits hit there.
Ooh, 128.
Control's been
130.
like 100% every now and then now.
Yeah, like right now.
Down to 123.
What did yours max at, Eric, just then?
Say again?
Did yours max as well? The IGT went up to 130.
No, I still got 105 at highest.
109
109.
for a super.
Thank you.
131. $132.
Trevor, let's slide it up an inch.
Coming up 1 inch.
Are you pausing or continuing?
Pausing.
Pausing sample.
Up 1 inch.
Copy that. 2121.
Commencing sample.
Okay, and restarting sample.
All right, we're down to 109.
Getting temperature reading at 102.
I have 115. 120. Just likes to grow.
Would this be an appropriate time to ask a question, Lee?
Stand by. I think we're just coming to the end of a sample,
Okay.
potentially.
Okay,
Sorry, Susan. Give me
no
a second.
problem.
Can we have a temperature update, please?
The IGT is 112. So far, the low was 107. And after recommencing, the high was 120. Before pausing, it was 131.
131 high.
I got temperature 100 right now.
And 100 right now on the super.
Spiking a little bit higher to 110.
Spike at 110, copy that.
Stopping sample.
Copy that, stopping sample, 2125.
You have an end flow count.
It's 67577.
67577. Thank you.
Bless you. Trevor, you pull the intake out.
Pull the wand where?
Just pull it out towards the vehicle.
Okay, come wide, please, Jess. I think so.
We have a final volume from that last sample.
15.6 liters.
Thank
I'm
you.
gonna put this into a purge port and run some cool water through it.
Yikes. That far enough away?
Yeah, I'm just waiting on temperature response.
Roger that. Standing by.
Would you
so.
like bubble on the flow meter?
I hope so.
What's up?
Oh no, so I was asking Eric if he would like bubble on the flow meter.
Oh no, I can see it right
You
now.
can see you're happy.
Just gonna run some nice cool water through there.
Is that essentially just flushing through the system, Eric?
Yeah, just flushing through a purge, so cooling all the chambers.
Yeah.
It's now a good time to answer that question.
Okay, someone wanted to know why do the temperatures of these what do the temperatures of these vents indicate, and why is it important to know?
You can take that, Lee?
Well, that's a very good question. I'm not a geochemist actually, so I don't want to hazard a guess as to why. I don't know. Maybe you'll be able to answer, Eric.
So the fluid coming out of these vents is not technically seawater. It's vent fluid that's driven down into the depths and actually acted upon with a lot of heat, which is why we're seeing higher temperatures coming out of these vents. So the chemistries will be a lot different than the chemistries in the surrounding seawater. And what we're interested in how this input goes into the ocean and changes the concentrations of chemicals that we're interested in, like trace metals and nutrients that are responsible for biological life. And the microbiologists are interested in how certain microbes would be growing around these vents. And so the chemistry is also important for them. So like 120 degrees Celsius is around the limit of any microbial life in these areas. And that's why the microbiologists were interested in keeping track of temperature while they're sampling, and hence why we have a temperature wand at the end of the intake wands. So when they were super sampling, they're taking in waters that potentially have microbes in them, and then they could culture them in the laboratory and see what grows in the community.
Thank you.
One thing we've seen today as well is how quickly that temperature dissipates over a matter of centimetres and millimetres, or millimetres to centimetres. It cools right down, back to ambient, relatively close to where the orifice is.
Hey Trevor, can we pull the intake wand closer to the camera and see if we did any damage to it?
Roger that. Let me turn on one more light here. Okay, zoom in, Jess.
Seems all right. Maybe a little discolored,
Got some
but
discoloration.
that still seems intact.
Yeah.
Looks good.
And you see, like the temperature probe that Sean has is like a centimeter away from where mine is. So
the end of your thermocouple is just there embedded in the base of the
that
plastic.
little
You can
small
see-
plastic or white circle, that's
Yeah.
where the end of the thermocouple is.
Why are there 2 white circles?
Yeah.
There's actually 2 temperature probes in there.
Wow.
But we had a problem with one of the bulkhead fittings and such. There's only one. It was so that we had a backup.
Roger. Good thing you did.
Yep.
So is
Okay.
this you done, Eric? Are you happy with your
Yeah, I'm happy with
11
the sample
samples?
set. Yeah.
Okay,
Yeah.
come wide. Are we going to stow this now?
Yes, we should stow it.
Okay, thanks.
I'll keep bubble on it.
Sure.
Can't find it. There it is.
Are we going to be doing outflow wand or whatever you call it?
No, we're not doing that. That's
Roger.
for microbiologists.
So just to recap, we managed to collect 11 super tube samples for Eric at a variety of temperatures, all within sort of 15 to 20 litres of water sampled. And for the majority of them, obviously for all of them, we had the super temperature wand working on all, and we had a couple of pauses with the IGT and the ICL. But for most of them, we had co-registered temperatures for all samples.
I'm just going to let this go.
That's great. Thanks, Eric. Thanks, Michelle.
Yeah.
Thank you.
Scoot over, buddy.
Scoot, scoot, scoot. Work with me. Work with me.
Doesn't want to go to bed.
I'll say.
I think it's demagnetized to the pokey stick.
We'll see.
Lee, we have someone from England who,
Oh.
who is curious about the deposits on the cliff. Are they what percentage is there any way of knowing if they're microbial mats or are they relatively thin coverings on the substrate?
From what we're seeing now in the field of view at the moment, I think what we're seeing now is actually quite a lot of hydrothermal deposits, so where the fluid is actually depositing, and I think it's actually from previous published papers, I think some of it is actually anhydrite. It's very friable, but we haven't actually sampled any at the moment, so we're actually going to look for a rock sample next. Not really necessarily a mineral sample or a hydrothermal chimney sample. So we're going to dig below and actually look for a basalt sample next. But I think there could potentially be some microbial covering here, but we're not seeing any of the blue ciliate mat that we saw yesterday around some of the other chimneys.
Where would I be going for a rock sample there?
Right, so we have instructions. So what we're looking for is a rock sample, again, similar to yesterday, but I think what we gathered yesterday, or what we sampled yesterday, was more of a hydrothermal deposit.
Okay.
And so our team at ISC is really interested in some basalt, which is in contact with the fluid flow, which means we're probably going to have to dig a little bit into that orifice we've just sampled there. So I don't know what the best course of action is. I think maybe to go in with the manipulator first, if you agree, Trevor.
Just a thought. I've
Yeah.
already... sorry, am I getting my days confused? Did I already knock some of this over?
You did.
So-
Did you or did someone else?
No, he did.
I think
You
I
did?
did. Yeah, right at
Okay.
the start of shift. On the left side there, I think there's
Correct.
some of our stuff.
Okay, yeah, that's all
Right.
chimney rubble. So that's actually all hydrothermal deposits. So that's not what we're interested in.
Understood.
Because I think if we grab that, it's going to be really friable and it's just going to crumble away. So we're actually interested in potentially that something is actually subsurface from that orifice flow at the moment.
Okay.
So I think we're going to have a bit of a
Dig.
dig.
Okay. That sounds like a pry bar job.
Potentially, yeah.
Okay. Okay. Let's get a plan here first. Do we want to kind of go in this zone here, or more over here,
What?
or
I'm not using them.
Okay.
up in the
I
back
feel like
over
we got
here?
enough samples
I
around
tell
this
you what,
area.
as a start, can you see to the left of center, just bottom left of center, there's kind of like a beigey color rock, not the black stuff.
This one?
No, left a bit more.
This one.
And again. And again. This guy. Yeah, can you squeeze that? Just like see if it's just gonna
Grip force
crumble
9.
away.
Full
Go-
grip force.
Yeah, go for it.
Okay.
Yeah, okay.
Yeah.
So, I think all of this around there, so I think all of the rubble, as you just said, that's just below your wrist joint now is actually all the deposit that was knocked down, and so was that large lump to the right-hand side as well. So I think, yeah, let's just go in at the base, maybe, of the orifice, and just,
Like here.
yeah, as long as you're happy with the temperature in your arm, that's not going to cause any problems.
Find out. I'll let you know.
Do we have the shovel to dig away material to look for hard rocks?
It's a plastic shovel.
Don't melt.
We do have the crowbar, am I correct?
Yes.
So,
It's
That's
more
really
of a
yeah, maybe more of a
gentle scoop than a shovel.
Maybe Herc smash.
Don't have to ask me twice. Yeah. Okay. Well, yeah. The crowbar is metal, so that's convenient. So, we should get a plan of how I'm actually going to do that, though. So
yeah, of course.
this part underneath the friable part is kind of
Yeah.
what we're after.
Yeah, under there. I mean, it's going to take a bit of time maybe to excavate around to maybe try and find something solid. It might be entirely possible that we're not going to find anything solid, but we're going to try and have a look to see if we can find something that is solid under there. So, I mean, it's entirely up to you. If you want to use, I'll defer to your better judgment. You've done this a lot more than I have, but whether you just want to poke with the arm and push down and see if you just push through that crumbly stuff, yeah, we're going to push off. Or whether you want to leverage with the crowbar a little bit.
So you can't really do much leverage with the crowbar. That doesn't really work so
Okay.
well, but it is good for poking. It's a little more stabby than the jaws, and
Okay.
it's more temperature tolerant because I don't really care about it.
Okay, let's do that then.
But that being said, it doesn't really break anything off.
Okay.
So I guess it depends on what our goal is. If our goal is to break off a piece here, but we're not happy with breaking off pieces from back here, I don't really know if I'm understanding the difference.
No, I mean, it's going to be subsurface. I think it's going to be under all of this hydro. So we've got, on top of what we're looking at now, is all this very friable